interestingly enough, the most fond memories are not about chemical engineering. They're about being part of UCL. And I think that was the most important thing for me, certainly as an undergraduate. The possibility, the opportunity to mix with so many people, students primarily, from a wide range of disciplines. So that helped me in all sorts of ways. Most fundamentally, my then girlfriend, who was reading history, is now my wife. So that was central, of course, to when I was a student. And it was through her that I met people, particularly in humanities departments. In fact, she smuggled me into a history lecture at one point, which was most entertaining. So that's the prime thing that I think about. I think when I think back to my time as a student, as an undergraduate student. As a PhD student, I think being a PhD student can be quite isolating. You're working on a specific project, you tend to be very focused on getting your thesis written. And it can be lonely, I think, but I was lucky to be part of a biggish research group. So there was a very good communal feeling within that research group. And I think that's one of the things you get out of doing research in a group. You collaborate, and at the end of the day, research is overwhelmingly about collaboration, I think. So those I think, are the two aspects of my undergraduate and postgraduate time here. As far as the Ramsay Society is concerned, it was very active during my undergraduate period. There was a biggish programme of works visits that was set up by the Ramsay Society, highlight being a visit to a brewery. So works visits were very important. The Journal of the Ramsay Society was an annual publication. I don't know whether it still exists. And I was editor of that for 1 year. And there was a great effort to get advertisers to contribute or to put an advert in to help fund it. And it was mailed out to all past members of the society, so it's an enormous effort. So those sorts of things in the department were very important. My other great love, in addition to chemical engineering, is music. And so I was very involved with the Music Society here as a student. I was in the choir. We had amazing performances. We sang Beethoven's Choral Symphony and other wonderful things. And we performed those actually because at that point there wasn't the theatre, the Bloomsbury Theatre, that had not been built. That was a bomb site actually when I was a student. And so we performed in Friends Meeting House on the Euston Road, where there was a very nice theatre. So that's where we performed. And then the other great activity of the Music Society was an opera that they performed every year, usually an opera that was less well known. And we performed an opera called Halka, which really is the Polish national opera. And what was exciting about that was that many people from the Polish community living in London, and that was a very large community, often left over from the war when a lot of Poles came to this country, they thought this was wonderful and all came and participated in various ways. So that was a very exciting activity. So I suppose those were the two things that I was mainly involved with, the Ramsay Society and music in one form or another. What attracted me to do a PhD is getting involved in a project, a substantial project, where the timescale is several years rather than several weeks, and get what I thought was to the bottom of that problem. Of course, you never quite get to the bottom of a problem like that, but you feel you can make a contribution to knowledge and drive knowledge further forward if you do something like a PhD project. I think that's what drove me to it. I always thought that I would want to have a period in industry after that, so that was always part of the plan. And at that stage, that was almost an essential if you wanted to come back as an academic in chemical engineering, that you obtain some industrial experience. So that was what I wanted to do, and it's what I did do. And as you people probably know, I work for ICI on Teesside in the northeast of England for the ICI's agricultural division, working on process development for fertilisers and to some extent getting to know the new ammonia process that they were then operating. And I spent 3 years there, which was a very happy time, and learnt an enormous amount, actually. It was a very good experience to have had, and lived with me in all sorts of ways. Crystals are of all around us. What do you put in your tea? You put sugar in. Look at that sugar when you next have some, and you'll see it's not just bits of solid. They are solid, or some of them will be with a very specific shape, and they'll have very flat sides. And the same is true with the salt that you put in your cooking. And that's extraordinary. How is it that this natural material, this natural solid material, is somehow formed so it's got very flat sides? What is it about that? And what that tells us is something about how that crystal is made up. It actually tells us something about what we call the atoms inside that crystal and how they are organised, how they are arranged. And so, in broad terms, what I was interested in was how those crystals were formed, how they came out of a liquid to begin with, how they grew bigger, how fast did they grow, because if you are trying to produce sugar crystals on a big scale, think how many crystals there are in a bag of sugar. Hundreds of thousands. So it's important to know how fast those crystals grow and what shape they grow. So that was at a very fundamental level. I suppose that's what my project was about. What I found as a pick going in with a PhD was that one thing you learn as a PhD student, a research student, is you learn how to use the literature. If you go in as just an undergraduate, you often don't get that experience and that skill. So that was surprisingly, I found that a great advantage. You knew if you were faced with a new problem, you knew where to go and how to get what was already known. You didn't have to do it all again. So that was the first thing. The second thing that actually was the most important thing in my time there was realising how multidisciplinary the research department there was. And that was fantastic. I worked with other chemical engineers, with chemists, with mathematicians, with physicists. And you realise, and that's lived with me throughout my academic career actually, the value of interdisciplinary work, which at that stage in the 60s, I don't think was nearly as well recognised in universities as it is now. Now there's so much interdisciplinary work, just as there is, especially in this department. It's amazing, it's wonderful. But 50, 60 years ago, it wasn't. But the impact you could make on a project if you brought in these other skills was really very rewarding. And there was one particular problem I was involved with, which was about the drying of fertilizer granules. Solid fertilizers are formed by a granulation process as solid pellets, really, typically perhaps 3-4 millimeters in diameter, solid. And when they're first produced, they're wet, so they have to be dried. And they're dried in a very large dryer, which is a long cylindrical piece of equipment, with lifters. So the bed of granules is sort of lifted up in the lifters. When it gets to the top, it falls down through hot air that's blowing through the dryer. And that, to understand that drying process, is a classic chemical engineering problem. Water's got to diffuse out of the granule. It's got to then evaporate, and the granule dries. But it's complicated because the granule is in two different sorts of environment. When it's in the lifters, it's surrounded by lots of other granules. When it's falling through the air, it's a forced convective process with air flowing past essentially a single. And my background wasn't sufficient to model that process, but there was a mathematician I worked with, an applied mathematician. We worked together, did some experiments, he did some clever modelling, and we really made an impact in that. We published a paper in Chemical Engineering Science, which was quite unusual from an industry. And that's always lived with me, that experience of how, faced with that sort of problem and grappling with and using the resource of another discipline, could take you so far forward. So that's the impact that ICI had on my subsequent career. Learn by watching other people. See what you think they do well, what you think they're not doing very well, and try and apply those lessons to the way you behave and the way you respond to problems or issues that you come across. The big issue when I was Vice-Chancellor at UMIST, or the big project, was merging UMIST with what was then the Victoria University of Manchester. That had never been done on that sort of scale before. It was a great opportunity, I thought, and my colleague at the university thought, great opportunity to develop a university in Manchester that really could begin to compete with the best in the UK. And it was a very challenging project, as you can imagine. Trying to manage academics is difficult at the best of times. So keeping the community on side with you was a challenge. We did it. We had great support from the City of Manchester, which is really my second home. I mean, I love Manchester. My parents were Mancunians, so it was very much felt like going home there. But we had great support from Manchester and local MPs for that project. And it was enormously satisfying to do that. And being awarded the CBE was something I never imagined would happen, but that's wonderful to feel that you've got that recognition. It's a great pleasure, great honour really, to be invited to be part of this celebration. 100 years of the department. It's amazing. 60 years ago, I walked through the entrance to the Chemical Engineering department into the head of department's office to be interviewed to see whether I was a suitable potential student. And I can picture that now. It's very odd. I can picture that interview now. And the first person I met was the then departmental secretary, Valerie Potter. And she was a stalwart of the department for years and years and years. And she could remember everybody. She could remember their name. She could remember their family, and goodness knows what. So it's a great honour, and I'm delighted to be a part of this celebration of a very important event.